Hello everyone, I'm going to solve this problem. You can pause this video and read whole problem. And please also see the image very carefully. Now I'm going to start solve this problem. Here you can see here that there is a collar and which will slide on a rod. On this rod there is a spring on the bottom side. And this rod is also inclined at a 60-degree angle. The spring constant is given as 1.6 kilonewton per meter and the mass of this collar is 2 kg and kinetic friction coefficient is 0.4. So we have to find the velocity at position B, and secondly how much this spring will be compressed due to this collar when it will strike. So I assume that the collar will come to the point C, and just remember that point C is not exactly at the bottom, it is somewhere between the spring. So before we start this problem, let's make a free body diagram for this collar because the motion will start from the position A. So as you know that we can first draw the vertical force mg in downward direction. That will be 2 multiplied by 9.81. Let me show you how does this collar will look. It is like a cylindrical. It has a circle inside or hole inside. So the rod will have contact with this inner circle, inner area. So we can say that there is a normal force in that direction as shown in this picture here. Also you can see that there is a kinematic friction, so there will be a kinetic force or friction force will work in opposite direction of the motion. I have made or chosen the axis, and in the direction of the motion we usually choose x direction, and in the perpendicular direction there is a y-axis. So let's balance the forces in y direction, and as you know that there is no motion in the y direction, so acceleration ay will be 0. Now let's balance what are the forces available in the y direction. You can see there is n very clearly in positive direction, and there is a component of mg in negative direction. So you can say minus y direction. So it is minus mg cos theta is equal to 0. And why we choose cos theta? Because this rod is inclined, so the component of this mg will be cos 60. So now we will solve this equation, and we can say that n is equal to mg cos 60. Now put the values for the m and g and the cos theta. You can utilize your calculator, and the value will be 9.81 Newton for n. Now let's solve for the position B, where we have to find the velocity. To find this velocity, we will apply the work energy formula, and in this regard we will solve by using kinetic energy correlation. So we can write T1 plus the work done from 1 to 2 is equal to T2. So T1 is A basically, and T2 is B point. So what is T? T is a kinetic energy at the position A. So I wrote 1 by 2 mva square plus the work energy is equal to the kinetic energy at position B. Just remember that at the beginning of this problem or the collar motion, the velocity of point A is 0. Okay, and there will be velocity at point B. Now let's talk about the is the work energy here. So we can look into this problem, and we can say there will be work due to the force, a friction force, okay. There is a spring also, and there is a gravity or by the weight, okay. So when this collar will reach at the point, so it will not engage a spring, okay. So a spring will be cancelled out, and we have to consider two forces here, one due to gravity and one due to the friction force. Now I'm going to write these equation, okay, for you by using the formula of work due to the force, friction force, and work due to the gravity or mgh. And you know that when we are calculating mgh, work due to the gravity, we take vertical distance, okay. And in opposite, in the friction cases, we take the absolute or the actual distance. So you will see in this equation, I am going to write equation, the T1 kinetic energy Ta is equal to half mva square is equal to 0. The velocity at point A is 0. The collar is stationary, okay. Now we are going to solve the work. The work is mgh, okay, because it's going downward direction, so you wrote plus mgh. Now you have to make sure what is h, and this h should be in vertical direction, right? So I will write the value 2 for the mass, 9.81 is for the g, and h. Look in this problem again, how we calculate this vertical h height. So here I am drawing this line, this is h, this is a vertical distance, okay, in x direction, in vertical direction, so this will be mgh. Now you know the kinetic energy at point A is 0. So I'm going to write the work due to energy. There are two work here, one because of the friction and one because of the mgh or weight. So I wrote the first for the for mgh, okay. So 2 multiplied by 9.81 multiplied by 0.5 sine 60. Sine 60 I have used because I need a vertical distance, okay. You can see here that work due to friction is negative. Why? Because this friction force was working against the direction of the motion. So in that case, I have used a negative sign for it. So now I will expand this equation, and for this work due to friction will be mu k multiplied by n and the distance. So we can write 0.4 multiplied by 9.81 multiplied by the distance 0.5. Now question is why we use the 0.5. So in case of the friction, we take always the absolute or actual or real distance. So in this case, it will travel, the collar will travel up to 0.5 meter, okay. So in that case, we have used the actual value of the distance. So we are almost done with this equation. We will put the all values. The only unknown in this equation is, if you can see here, that is VB, the velocity at the point B. So now equation becomes very easy. There is only one unknown, so you can find the value for the velocity at point B, which is 2.56 meter per second. Now let's solve the second part of this problem. Here we have to find how much spring is compressed, because when the collar will strike, the spring will compress, and of course spring will not reach up to C. Okay, so there will be compression and there will be distance somehow between the B and C. So we will say that that is the distance x. Okay, so in that case I will again use the equation, work energy equation, using the kinetic energy. So I can write from the A to the C equation. So kinetic energy TA plus UAC is equal to TC. Now things are very similar to the first part. You know that at the beginning of the problem, the velocity A is 0. So kinetic energy at the point A will be 0. And as you know that collar will stop at the point C, because spring will get the maximum compression, and after that point, after compressing the X point, it will stop. So we can say that velocity at the position C will be 0. Okay, you understand that X is the distance where spring will stop also. Okay, stop under compression. So at that moment the velocity will become 0. Now we have to figure out what are the work. So in that case, from A to C we can see that there is a work due to the weight mgh. Secondly, there is a spring compression, so we can say there is a work by the spring, and there is a friction. Okay, so we can add or remove the work due to the friction. So I will write all equation. The mgh will be positive because it's going down when the something is falling down. The work due to the gravity is positive. Then you have to minus the work due to the friction. So you can write simple formula, Fk multiplied by ds. ds is here distance, and minus half kx square is for the spring work. When a spring, remember it, when a spring is compressed, we put the value for spring work as a negative here. Okay, so here the spring dimensions are decreasing. Okay, so the total work will be the minus. Okay, so that case it is minus 1 by 2 kx square. And also see here that the work, the friction work is against in the direction of the motion. That's why we also put here the negative, and mgh is positive. Guys, if you have any problems from the engineering dynamics, you can write your problem in detail in the comment box. I will try to make a new video for it. Thank you. Now put the value for mgh, and then friction work, and then spring work. So it is easier, you have all values, you can just put the values here. But mind here that when you are writing the value for h, the h will increase. For mgh in the vertical direction, it will increase. Okay, so you have to take a vertical component of 0.5 plus x, that is sine 60. And also in friction work, there will be increment of plus x. So you can write 0.5 plus x. okay, and then you will simply write 1 by 2 kx squared. Mind it here that you have to write the spring factor in just Newton per meter. Okay, so guys, just quick reminder that when we are solving in the work due to the gravity, we use vertical height, okay, and when we are calculating the friction factor, we have to go for the actual distance it traveled. Okay, it may be a curve, it may be a incline or anything. Okay, please don't forget to like and subscribe. Thank you very much. Have a nice time. Let me know if you have any question. You can write your question in the comment. I will try to solve it in the next video. Thank you very much.